Not yet.
Getting there. It's slow. Okay.
There we are. Okay. All right, let's right. We come now, having had rather a heavy dose of triggers and user spaces and all sorts of funny things. We come to the last of the DB2 functions, which is the constraints. So just a quick recap of the components that make up DB2. First of all, there's the physical database. These are the actual physical tables that make up the physical database. And that, of course, is the database. The next function or component of the database are all the logical constructs. Now, please just remember there are 6 of them, not 3 like most people want you to think. There is the 3 DDS constructs, the index, the join, and the multi-format logical. And then you've got the 3 SQL constructs, BR index, EV index, and join. So you've got 6. You need to use the one that's most appropriate for whatever you're trying to do. But it is better, particularly for interactive environments, if you build logicals rather than do multiple IOs or built-in SQL. Now, input-output servers, we've talked a lot about those over the last few months. And although they're not officially a DB component as far as IBMI is concerned, I consider them to be a database component from the database management point of view, because of the reasons that I've given you with access control and so on and so forth. So that's why they're in green, not blue. Trigger programs, the second heavy lifting component. We've done a lot of talk about that. And you guys are going to need to try this out by using those 2 programs that we have in your ABC train schema, and really try and build trigger programs for those and see how they work, because you can put so much into both before and after triggers. Then, of course, you have the journals and receivers, which are necessary to enable commitment control. Commitment control being a very, very prime management tool in the database to stop you or having partial updates to the database, etc., etc. So commitment control is extremely critical and is a major component of the DB2 components. You should not run tables without commitment control and journals and receivers unless they are genuinely work files of some sort, where you really, really, really are not interested in keeping them after the event. Anything else must be under commitment control. Right. Those we've all dealt with. And we come on to the next and final component of DB2, which is also takes a lot of effort out of your application code and provides huge functionality without having to code for it. There are 4 constraints. The first one you're pretty familiar with. These are primary keys. All tables in your database should have a primary key. A primary key, by definition, is unique, and every table should have one. The second one are unique keys. These are unique combinations of fields in addition to the primary key so you can have a second uniqueness applied to a database file. The example I always use is if you have a customer master file, it's got a customer number that's a primary key. Because it's a primary key, you can't duplicate it. But it's possible to duplicate the customer's name, which will sow confusion when you've got two customers of the same name with different numbers. So you could add a unique key based on the customer's name so that you could never have a duplicate name. Or many other reasons, and there's another use for unique keys, and I'll come to that right now. We have another constraint, which is a check constraint. We'll talk about that in a little bit of detail. And then the fourth one, which is the most powerful of all of them, is the referential constraint. It defines the relationship between two files. And that is hugely powerful in terms of taking a load off your application code and preventing orphan records. So let's have a look at these. First of all, primary key. I don't know whether I need to fuss with this too much. One or more fields make up the primary key. A primary key at the present time, as far as I am aware, has a maximum length, all fields combined, of 2,000 bytes. I think that if anybody puts a primary key on a file anywhere close to 2,000 bytes, they should be taken out and strung up, because there's something wrong with the design of that file if you need a key that long. So it's again typical IBM. They give you a limit, but the limit is ridiculous. You should never even try. What's the saying? Just because you can doesn't mean you must. The order in which the fields are defined provides the index sequence. The first field in the key is the most significant key field. The last one is the least significant key field. And there can be any number as long as the total doesn't exceed 2,000 bytes. And this is important. Only the primary key is available for RPG keyed access. You can't. The primary key is equivalent in an SQL table to the K-spec in our DDS. K-specs are in fact primary keys. So those are the three bits of information that you need about primary keys. And please, every single physical table in your database should have a primary key. I'm going to go on about this a little bit now, a bit later. Right, let's have a look at the unique constraints. One or more fields out of the database, including fields that are part of the primary key and other fields that may not need to be part of the primary key. You can create a unique key, and which is an additional uniqueness on that file. And intriguingly enough, there's no limit to the number of unique keys you can have on a file. You can have 200 of them if you really want to make your life complicated, but obviously one has to choose a reason for doing this. So where's Joel today, Bernard? Is he on leave again?
Joel is sick today.
Oh dear. Okay, he's going to have to catch up then too.
Yes.
Yeah, I just noticed he was missing. Okay, so you can create one or more unique keys, which will control. You cannot violate a unique key just the same way as you cannot violate a primary key. So if you attempt to put a record on the file that duplicates a unique key, it will throw it out. This is mainly used by RDBMS and is not available for direct client usage. This means you cannot read a file in RPG by using a unique key because you cannot get at it.
Tommy?
Yes?
Just for an example, in the way that you have an employee table, that the employee number is the primary key, then, for example, you could decide to define the social number as a unique key to be sure that when you're going to write a new record, then you'll be sure that there will not any duplicate for a specific data. Okay.
Social security. Yeah, that's a good example. Better than my customer. Yeah, you make sure that the social security number is unique as well.
Okay.
That's correct. Can be used as a parent key for a referential constraint. Now, this is interesting because we'll come to the referential constraint, which defines the relationship between two files. But a unique key can be used in a referential constraint. We'll talk about that when we get there. Right, here are, strangely enough, your referential constraints. A referential constraint defines the relationship between what IBM calls a foreign key file, that thing. I don't know where they got that term from. It really is ridiculous, but I use it because it pitches up in all their manuals. It's the relationship between a foreign key file, or in my language, a dependent file or a child file, in relationship to a parent. This is a definition of the relationship between two files. The parent file has to have a primary key and a unique key is optional. So the parent file can have a primary key, must have a primary key, and could have one or more unique keys. The foreign key file requires fields that match the parent primary key or a unique key exactly. Now, the name of the field is irrelevant, completely irrelevant. It is the attribute of the data and the sequence that is required to match these two fields. So if this parent file has a primary key of staff code, staff number, or whatever you like to call it, and you want to attach one, then there must be a matching field on this file, which matches by attribute and position. Now, it can match either to the parent primary key or to a unique key defined on the parent. So you can have two files relating to a parent file using different unique keys. Does that make sense? In fact, I can have a dozen files which relate to a parent using a dozen different keys, one primary and 11 unique keys. Never going to come across it. If you do, find the person and drown them. Okay. It's not a good thing to do. Let's have a look. The constraint you define on the foreign key file, and you point to the parent file. So the constraint is defined on the foreign key file, and it tells you what the parent is. So this, the way that I annotate this, the round thing is a many, and the arrowhead is a one. So this is a many to one relationship, which means there can be many records on this file with the same matching key on the parent. Now, one to many is normal, but it requires that the foreign key file has more primary keys than the parent file. If you use the foreign key file and you match exactly its key to the parent file, then it must be a one-to-one relationship if the keys are identical. Does that make sense? Or am I confusing you? If the foreign key...
I'm confused. Please put some example.
Okay. All right. Let me see if I can give you an example of this one. We'll come here, bring this into play, and I will look at, in fact, I'll look at the ABC train environment where we have prod ord. Okay, now I'm going to open up this and I'm going to show the keys here. You see, here we have prod ord that has a unique key. This one, which we want to relate to that one, hasn't got a key. So the first thing we have to do, because the rule says all files must have primary keys. But in this particular case, I don't need a primary key in order to relate this to the product, to the prod ord. So I'm not going to do it just to give you an example. This one is an arrival sequence, but I can provide it with a constraint. I hope I can. It's this is AO is actually doing this job. I can choose. There's a referential constraint. It gives it a default name. It's a name that I will talk about default names just now. And the foreign key, i.e. the key on prompt IP7, is this one. Now, I can then choose the parent file to be prod ord, and you'll notice AO picks up the parent key because it has to be, this is a parent, it has to be the parent, full key for the parent to match. So that is in fact a constraint, a relationship, and I can set it up. It's fine. And I can refresh it. And there is the definition of the dependency. The dependency has been defined for that file. And the foreign key, the P7 ncom, and the no com on the prod ord is what joins these together. Now, because you know there's more than one P7 ncom on this file, because there's a second key, which you don't have here, it means that this is a many-to-one relationship. Let me put the key in here. I'm going to put the key into this because we agreed that this needed to be done anyway. There's your first primary key. Now, if I make this, let's just start here. If I say that this key is unique, so I'm only going to put on that key. I've got to actually create that file. Sorry. Just checking to make sure it's done everything properly. Yeah, there it is. Okay. I do these things off the cuff, and you catch me every time, Bernard. You know you're good at this, eh?
It's really
It's a talent, is it? Yeah.
but it's
Why did that key not go on? The key didn't go on for some reason.
it's strange because we're working on the detail file.
Ah, there it is. I don't know
And-
why that key didn't go on, but it's now on.
Yeah.
Yeah. So this won't work. If I apply this key, it's not going to work because you will have duplicates. Do you agree with me?
Yes.
Chroma 7 will give me duplicates.
You need to have the sequence.
We need to have the sequence on it. So we're going to change that to add this one.
Yeah.
There we are. Now we have, that is the key of this record. I'm going to just recreate the file again so that we can make sure that it has the right. Yeah. So in this particular case, that field, P7 NCOM, is related to NOCOM there, but this file has another key, which means there can be more than one record per P7 NCOM. So that would be a one-to-many relationship, because there can be many records pro MIP7 equal to one prod ord. Does that help? If the two keys are exactly matched, there can only be one on here or one on there. Okay, I haven't got it clear. We will actually come back to this because I have...
No, but it's more clearer, but it's
Okay.
just that when you're working on the foreign file,
Yeah.
it's you define a foreign key, but you are in the file itself.
Yes.
But you have to call it a foreign key. It's a bit mixing up.
This is why I find foreign key a bit ridiculous. It's a dependency. It's a dependent file. It's a parent-child relationship. That's what it actually is. You can have a one-to-one relationship if the keys match and are equal, or you can have a one-to-many relationship if there are likely to be more records on that file with the same key that you match up to that file. Yeah. And remember,
P7 is a child. That's it.
Yes, definitely.
But if I understand in this case that if I'm trying to add a record in the P7 with a NOCOM that doesn't exist in the proder, then it will be rejected. It will be rejected.
It will be thrown out, yes.
Because it's going to verify that the NOCOM exists in the proder as soon as you add the record. Okay.
This is what your relationships do for you.
Okay.
You cannot delete a parent if it's got children, and you can't add a child if it doesn't have a parent.
Yeah.
And the database does that. You don't, not even a trigger, nothing. It happens in the database management system. So it's very efficient, and it makes sure that you don't get orphans.
Do you know, Tommy, if you are doing a copy file or create duplicate object, does it mean that you need first to create the parent file, and after that just copy the foreign key file? I mean that in situation that we copy the file in the test environment, then we need to do in the good sequence to copy first the parent file and after that the foreign key file. Okay.
If there's a referential constraint between the two, you have to do it in that order. You copy the parent and then the child.
Okay.
Not the other way around, because otherwise if you copy the foreign key in first, it won't copy. It'll say, got no parents.
And is it possible to inactivate the constraint?
Yes. You can disable it if you want to, and then you can re-enable it if you remember to. Let me say this. The number of times I've had to bail people out of problems with their database because somebody disabled a constraint or a trigger and forgot to put it back again, I can't count. It's the most common problem of a IT department, where somebody wants to do something, so they take a trigger or disable a constraint, and then they forget to put it back again. And believe me, I've seen it done in production too. I'll show you how to manage that one very carefully. Okay. So here you are defining relationships between files. And this you can nest. My foreign key file in this join could be a parent to another one. And that foreign key file could be a parent to another one. Or one parent can have 6 foreign key files. You see what I'm saying here? I'll show you a diagram I've got it at the end of this, which gives you a better perspective of the sorts of things you can build using this. And remember, this is so simple to create. You saw me create it. If I wanted to do it by hand, the command is add pfcst. That's the command that allows you to add a constraint to any file. AO does it for you because it then keeps a bit of control over it. And it keeps it documented, as you can see here, and it tells you everything about. I can switch that off if I don't want to see it. I can switch off, hide the constraints, or I can turn to the constraints view, so I'm looking at constraints only. That's quite you can manage it oh, you didn't see any of that. All right, sorry, I'm losing it now. Let's move on. Let's look at the next one, check constraints. A check constraint is a SQL where clause without the where, defining conditions to be checked as true. For example, field A or record code. You've got a record code. Record code in list XYZ is a where clause in SQL. You can put it into a check constraint and the database will check that the value you try and put in that field is only X, Y, or Z. You follow me? It's a simple check of... Sorry?
Similar to a before trigger validation?
Well, this is exactly the point. People ask me, when do I use a check constraint and when do I use a trigger? And my answer to that is, well, because I usually put a before trigger on every single table that I create, I never use check constraints because I don't want my validations in 2 places. Also, with a check constraint, you don't have control of the message that it returns, whereas in a trigger, you can manage exactly the message that is returned. So to be honest with you, I put this in for completeness, but in fact, I never use check constraints. It's very useful to do add a quick check, a yes/no flag. People say, yes/no flags and that sort of thing are easy to put in with a check constraint. They are. But as I say, you have no control over the message, and you've got validation in the trigger and in this constraint. It makes it much more complex to manage. So although it's there and I put it in for completeness, I would only use it if there's no reason whatsoever to put a before trigger on the file, and therefore I want to validate one or two fields. That was the only reason I use a check constraint. So really, the constraints that I use mostly are primary key, unique key, and referential constraints. So let's have a look at this. I have a naming convention for constraints because I like to know quickly and easily where they are and where they're coming from. The first one, primary key constraint. I use a table name, and because you can only have one primary key, underbar P, that's my primary key name. Now you say name for a constraint. Why do I name a constraint? Because IBMI sees a constraint as an object, a separate object in its own right. And you can store it in a library other than the library in which the file is stored. Now, if you hear that correctly and you think it's as crazy an idea as I do, then you're right. But it's possible to do so. I'm going to show you here. Add BFCST, add physical file constraint. We'll call file, doesn't matter. And the constraint type will be ref. Hit the enter key. Here it asks me for the constraint name. And gen means the system is going to generate it. Here's the parent file definition. Ref, sorry, I've got it wrong, CST in this particular case. Delete and update rule. Oh, that's interesting. That is extremely interesting. They've corrected this. They fixed this. I don't know when they did it. A unique constraint has just got a name. Let's go and have a look at the specify the name of the constraint. The constraint name must be unique to the library of the physical file specified on the file. I have just told you a lie. They used to be able to have your constraints in different libraries. You can't anymore. They must have changed it, and I never noticed. Well, I'm very grateful for that because it was a silly idea anyway. So you can give it a name. You can refer to it as a name because you can refer to the constraint by a name. It is a separate object and exists in the library where the file is. So you need to give it a name. Now, in my standards, my table names are all 7 characters long. As a result, to put an underbar P at the end is no problem. Your standards are different for file names, and you may be able to use the underbar P, you may not be able to use it as the name of a constraint. Please do not let the system ever generate a name for you. AO won't let you do it. It will generate the name automatically. So It will generate the name by default automatically. So you have to decide on a convention. I would suggest you do, because when you look at a constraint name, I can tell exactly what table it's attached to, what foreign key table it's attached to, or what, in this case, what physical table it's attached to. Unique constraint, underbar UN, N being a number from 0 through 9. I have never ever had to use more than 2 as far as I know. So, but it does indicate that you can have more than one unique constraint on a file. Check constraint, CN logically, and referential constraint RN 0 to 9. I do have a spare character because my table names are 7, 8, 9, 10. I can go higher than 9 by using letters A, B, C, D, E, F, G, onwards, upwards, that way. So, but I've never had to do that, and I hope you never have to do that. So those are the 4 constraints and the naming conventions that I use. Now,
For me?
Yeah.
For me, unique constraint. You said regarding the check constraint, we don't have any control on the error message.
The message.
So the message on unique constraint, is it the same thing that we will not know too much what's the problem?
You will get a unique constraint error if you try and add a record that violates that constraint. You will get a system error message. Yes.
But no much detail about the field.
No, that's the problem. Usually you get a primary key error first, I've noticed, but I have within AO, and I can show it to you, I have a method whereby I can translate constraint errors, system-generated constraint errors, particularly referential constraint errors, because the same applies to referential constraints. Because the system is checking them, you get a system error message. So I have a method where I can translate a referential constraint into a more meaningful constraint message to be sent to the user. That we can deal with when you get your handle on this and you decide that you're tired of getting system names and you want to have your own messages come through. Okay.
Okay.
But it is a thing that I have addressed in AO. I've provided a file which does translation for this. Okay, so now just to tie this whole thing together, let's look at a little database that I have put together. It's not a difficult database. It has a customer master file. It has a representative master file. This is more or less an ERP system. It has a customer balances file and a customer address file. This is all the various aged balances for the customer. These are the various different types, addresses and types of addresses that for the customer. Invoice header, invoice detail, and product master file. I'm sure you can all relate to this one. So let's see what we do to make this all happen. So the first thing we do is we add before triggers to all the files. And we go through these files and we validate everything except relationships, because we put in a relationship there. There's a rep code on this file, so it's a many to one relationship, because the rep code is not part of this key. at all. So I can have many files with the same rep code relating to that. So this is the foreign key file. This is the foreign key file, and that's the parent. And I don't have to then validate the rep code on the master file because it's already being checked there. Then we add another relationship here. This one, however, is a one-to-one relationship because it's the customer code and the customer code are both keys on that file. There's a one-to-one relationship, i.e. you can only have one balances file for each customer. That's why it's a one-to-one. Right, then let's look again at what we can do here. The address file to the customer master file is a one-to-many relationship because you can have multiple addresses, each with its own unique key, but with the same customer number. So you have a one-to-many relationship there. And again, you don't have to check that in this before trigger either because it's done by the database. By the way, databases validate relationships before passing control to the trigger program. So the trigger program doesn't even get called if there's a relationship failure. Here's another one. Invoice header file, many to one customer, many invoice headers. And of course, many invoice detail lines to an invoice header. And of course, the next one would be a relationship here, product code to product master. Many to one. So within this little database, I'm just looking to see whether that's the end of it. Yes, I think it is. Within this little database, you can see I've tied the database together with referential constraints and primary keys. Every one of those files has to have a primary key, and they all have referential constraints. So those relationships I don't have to validate in the triggers. Now, this is an interesting one. I threw this in because it's a concept, a simple concept here, is that in my invoice detail file, I have a space for a price and a total. But I don't want the user to type in the price or have to calculate the total. So what I do is in the invoices before trigger, I take the product code, I go and fetch the product master file, and I get the price off the product master file. It means it's central pricing, and the instant I change the price on the price master file, it will percolate throughout the system without a problem. So there's nobody's entering a price. This before trigger will take the quantity, multiply it by the price, calculate the amount, calculate the tax, the discount, and all that sort of thing, and put it into the detail record. This does not need to be done by the application code. So the relationships are forced, and then you can use the information in the before trigger to do a lot of work that you then do not need to do in your application code. And this is a good example because very often when you're selling a product, you want to get the price, you've got tax or VAT to calculate, you've got quantity discounts, special discounts for good customers. I don't know. There's many of things that you might want to calculate in to come up with a total price, which you don't want to put in 16 different places. So that's one trick you can pull there. Here's another one. Here, you could put after triggers everywhere, but it's not necessary to do that. I find that you only need after triggers in certain definite circumstances. Now, the one here, you can see there's an after trigger on the customer master file. And that after trigger is designed to maintain the customer balances file. There's the blue line. So every time a record is inserted, updated, or deleted from the customer master file, the after trigger will change the balance accordingly. That's great. Here, an after trigger on the detail file, invoice detail file, can also be used to change the balances. Maybe the balance file has an on-order quantity or an invoice quantity. The after trigger on the invoice detail file can maintain the balances file as well. All of these things are possible without doing one line of application code. And once these are done and tested on your database, you never have to look at them again. And this is where you get a huge reduction in code lines and a huge improvement in quality of processing, because these are single things that are put together, tested, and made sure they work, and then they are left alone and not touched. Never have to be tested again. So this is a little picture of a tiny little database. Obviously, yours is a lot bigger than this. And you're not going to try and do this all at once. You begin slowly and carefully, one little place at a time, to be able to eventually grow to this type of control. Any questions? Did it answer some of yours, Bernard?
Yes, it's I see that there's a lot of place where we can put foreign keys.
Yes.
Constraint.
I'm very sure. Now, I'm going to have to now talk about one thing to do with referential constraints. I didn't put this on a slide because I forgot about it.
I have a question, Tommy, for you.
Yes, please.
Actually, we are put the trigger program in the same schema as the file. For example, our file is the BIL OPR DFL, and this is the schema for our database file. And we putting the PGM program within the same. Is it the same for the constraint? Is going to put as the same schema as the
constraint
as the
goes,
database, but because you talk about that we can use a different schema to put the constraint.
It used to be like that.
It used to be like that.
It used to be like that, and I have just checked it. If you say add PFCST, which is the add physical file constraint, and you prompt it, if you put in, for example, a star ref CST, it used to have a parent, a library, a target library or destination library for this, and it used to keep it. Now I see that it's changed, and I didn't notice that before. because I've been adding these through AO, and AO has never ever thought of putting it in another schema. So they've taken that out. It automatically goes into the same schema as the file.
Okay.
The constraint. Even though it's a different object, it goes into the same schema as the file. Okay.
I'm trying to understand the way that, for example, we are buying a new server and we need to restore all the database in the new server. Then first of all, we need to detach all the constraint first.
No,
because in the restore.
When you do the backup, all constraints and triggers, if you keep your triggers in the same library, same schema as your files, your constraints are in the same schema as your files, you back up that schema. It backs up everything, including the definitions of the triggers and the constraints. Okay. Those are all backed up. So when you restore, you would restore everything, triggers and constraints, back to the way it was. Because although they are different objects with their unique names, they are tied with the files. They're hooked into the files.
My question is we need you talk about you said that we need first to restore the parent file, and after that later the foreign key. Then if the parent files have for example a name with a T and the foreign key has a name with A, then the foreign will be restored first before the parent.
Now you understand why my physical files have got a name with an F on the end, and my logical files have got FA, FB, FC, FD. Because when I do a restore, naming like that, restoring alphabetically, the physical files get loaded first. Okay? Then the logical files and the dependencies will also come in, maybe out of sequence. Now, the IBMI is smart enough to know that if a dependent file is loaded before its parent, it won't activate the constraint until the parent has been restored.
Okay.
So it does handle that. The big problem is if you have alphabetic logicals coming before physicals, because what happens then is you're restoring a file, it restores the logical and builds the access path for the logical. Then it comes across the physical, it restores the physical and rebuilds the access path for the logical. So if you load the logicals before the physicals, you get double access path builds. That's why I have made sure that my physical file always comes before my logical files.
Okay.
All right. But
it's worth trying to do also.
It's worth it. But obviously you have a standard and you've got to be very careful about changing names because, you know that they can cause an awful lot of problem if you change the name of a file. So, So this is, now I want to point out on this particular add PF constraint, if it's a referential constraint, you get these two parameters. Now, the update rule I don't use. I just say no action because it really doesn't do an awful lot for you. It's to do with updating the parent and restricting the update on a parent if it's got a dependent, and it doesn't be a great deal of use. But this one, the no action rule, or the delete rule, has a number of different options. Cascade, no action, set default, set null, and restrict. Now, no action. If the no action rule is used, the delete rule is enforced at the end of the delete request, i.e., that is after the trigger has done its thing. Deleting a record in parent file is permitted, not restricted, if data for a non-null parent key does not match data for a foreign key. Deleting a record in the parent file is restricted if data from a null non-parent key matches data for a foreign key. So no action says you can't delete the parent if you have a dependent record. Okay, this is your referential constraint. Remember, this constraint is defined on the foreign key file, but we're talking here about deleting a record from the parent. If it says restrict, deleting a record in a parent is permitted if data for a null non-parent key does not match for a foreign key, and this one is restricted if it does match. The difference between no action and restrict, I have never been able to understand or determine. I would assume there is something different. The no action is enforced at the end of the delete request. The restrict is enforced at the beginning of the delete request. That's the only difference I can see. So I'm not sure how it affects what actually happens, because what actually happens is exactly and precisely the same thing. You can't delete a parent if it has a child. But this one is very useful sometimes. The cascade delete rule, deleting a record in a parent file causes matching records in the dependent file. And I'm talking here not about one dependent file, but all dependent files to be deleted when data for a non-null parent key matches data for a foreign key. So if you use the cascade rule, all the records in your foreign key file will be deleted if you delete a parent. I.e., you can't accidentally delete a parent and leave orphan records in a foreign key file. But if you have 6 foreign key files for one parent, and one of them has a cascade and the others don't, it doesn't work. Follow what I'm saying? They all have to be cascade. And if you have them nested, all of them have to be cascade. Otherwise, they won't. One of them will stop the whole process from happening. Cascade I use quite a lot, but there's a trick, or there's a problem with it, and I'll show that to you now. Set null, I never use. The set null delete rule is used. Deleting a record in the parent file updates matching records in the dependent file if data for null non-parent key match. If the matching foreign key field is null capable, the value is set to null. So what happens with this is that the keys, the fields in the dependent file or foreign key file are set to null. The record is kept there on file. The dependent record is on file, but the key fields are set to null. This one is simple. It's the same thing, but it sets the dependent key to its default value. Neither of those I use because I cannot see the purpose behind them at all. Cascade and no action are the two that I use the most. But there's a caveat with this cascade. If you have a relationship between two files with a cascade delete rule, you cannot use before or after trigger programs on either of the two files. Now, the implications of that are sometimes a little complicated to follow. If I do cascade rules on my files, if I use the delete rule as cascade, I never have to worry. I delete a parent, it goes through my whole database and erases all the records that should be erased, and I never have to worry about it. But if I want to, let me try and think of something. If I'm deleting an invoice line item, or I'm deleting an invoice from the file, it requires that I delete line items, and the deleting of line items need to alter the balances on my customer balance file. Let's go back to this picture here. If I want to delete an invoice here, and I cascade delete the lines, this after trigger here, sorry, this after trigger here can't be called in a delete circumstance because this is a cascade delete here. So it can't maintain the balance file because it can't use the after delete trigger. I actually did some research on this to try and find out why, and it's an internal problem because of the sequence of events that happens when you use cascade deletes. It just cannot support delete before or after delete triggers. So one has to make a choice. You can do the cascade if you don't need to use after deletes, or you can use after delete triggers to remove dependent or foreign key records. Do you understand what I'm saying? If there's a delete here on this header file, whoops, sorry, I always do that. If there's a delete on this header file, I could have an after trigger here, which makes sure that I delete all the detail file records. And because I'm deleting detail file records, there's an after trigger here that would update the customer balance file. So you either use a cascade delete and understand that you can't use after delete or before delete triggers, or you don't use the cascade, and any cascade activity that you want to perform, you have to build into the trigger. Not all that difficult, particularly if you're using IO servers. It's pretty easy to put cascade deletes in place on a trigger. But you've just got to decide which is going to work best for any particular circumstance. And I have no advice other than that to give you. In fact, I've been caught a couple of times where I've used the cascade delete because it's the easiest solution. And then later on, I found that I actually need an after delete trigger. That means I have to then rethink that whole construct, get rid of the cascade, put in the after delete trigger, and then add code to other after delete triggers to actually get the cascade to work for me. So it's worth giving it some serious thought before you use one or the other. Okay, any questions?
Does it mean that I can use both? I mean that I have an either detail and doing a cascade just to delete a record from the header, and is going to delete the details also. Yes. And could I use also the trigger for the details to do something else?
Not an after delete trigger or a before delete trigger. You can use an after insert and an after update, but you cannot use the after delete trigger. That's
Okay,
the problem.
then I can't use the after trigger for delete for the foreign file. Okay.
If you've got a cascade. But if you want to do that, you take the cascade out, then you can use the after trigger, the delete, to delete the foreign keys file.
Okay.
So yeah, it's one way or the other. It's not, unfortunately, both.
Okay, but my question was about the parent. You know, I'm doing a delete in the parent file.
Yes.
Is doing a cascade to delete the records within the tails.
Yes.
And for the details, I have a trigger just to keep, and I can't.
You can't have it on either of the two files. You can't have a before or after delete.
Okay, because the cascade will just delete. That's it.
Yeah, that's it.
Okay.
So you can't react to the delete from a cascade. That's the problem. You have to then build that cascade into your trigger. Then you can make it happen.
Okay.
All right. I'm sorry I'm giving you all these headaches, really. I wish I didn't have to, but that's the way life is. Right, let's move on. Oh, it's a sunset. While we look at the next topic. This basically brings me to the end of the RPG techniques skills transfer. It's the whole process of enabling your database to take over a lot of the work that your application is doing, to start the database to do a large proportion of the heavy lifting by making these various changes, triggers, IO servers, and all those sorts of things. So this basically is the end of that process. You've now got to start. I don't suggest you try and do it all in one weekend. I think Francis said you're going to take 2 weekends, or it was Joel, I'm not sure.
Just that was Joel.
That was Joel, yeah. He was being a little bit optimistic, I'm sure.
He's not there, so we're going to say that it's him.
We can say what we like. So, but it's a process. It's not something you're going to do very quickly. You need to look at this whole philosophy, as I do. If I'm going to change something, or I need to enhance, or I need to write a new function or put in a new file, follow all the rules. Follow all these new rules. Eventually, you might... What was the one? Half the database was now new. The other half hardly ever changed. Don't touch it. Don't waste your time. Unless you've got programmers sitting around doing nothing. Bernard, understand this. When you start putting these things into place, your guys are going to find that they can do things quicker and easier, and eventually they're going to run out of work to do. They're going to be sitting.
So?
Yes, I know so. Eventually, they'll be sitting there twiddling their thumbs, and when you catch them doing that, you can tell them to go back and change stuff that you haven't touched in the last 52 years. Okay? I'm sure. Because everything becomes easier and faster and quicker and more accurate. I'm not saying that it's likely to happen in your case, because I have no idea what your application is all about. Okay. So this is really, I'm going to now, before we start to move into the topic of the, what do I call it, the graphic interface, I want to just go through COD and COD's 12 rules for the database. I haven't mentioned the word normalization to you in the whole time we've been together, and I don't intend to mention it now. Yes, Marinas.
Tommy, are you going to talk at all about how to manage adding constraints to their files if there are orphan records within the files, etc.?
I forgot all about that. I forgot all about that. I'm sorry. I've got to go back, guys. Marinus has now smacked my head. Okay. I'm going to use, sorry, there's one thing I did miss here. And I need to, when you add a constraint like I did here, I've got a dependent file and a parent. Now, I'm going to use DFU because I don't have anything else. So I'm going to edit my library list. And I'm going to put A, B, C, T, A, I, N into the library list. Oh, it's already there. Goes to show I was smarter than I thought. Okay. DFU, prod.
It's update data.
UPDDTA. You can see I don't use this very often. Right, now I'm just going to pick any record. Okay. This is, I'm just going to scroll down to somewhere around about here. Then I'm going to use option 23, I think it is, to delete this record. This is the parent record. And press 23 to confirm the deletion. And you will see DFU is not very smart. So it produces a CPF 503A. And if we look at 503A, an unexpected error occurs when DVU, etc., and we display messages in the job log, and we go to the bottom, and there is your referential constraint violation. The operation being performed on prod ord file in ABC train failed. This constraint, there's a constraint name, prevents the record number 17 from being deleted from prod ord of the parent file, etc. So that shows you how you can avoid this business. Well, how it protects you from deleting something that has dependent records. Because I did not add this as the delete rule was no action, so it wasn't cascade. So it didn't take out the records. Now I'm going to add, I'm going to actually disable this constraint. Let me just show you how you do that. Work PFCST, work PFCST, all files, ABC train. This work physical file constraints is a very useful command. It shows you, that's interesting, all the things that, all the constraints that are active. Primary keys, here's a, you'll notice that these are the constraint names that were defaulted by that star gen default value on naming. And actually, if we press F22, you see how long a name it gives you. It tells you all sorts of things, which really is just too long and complicated. So, right, here's the constraint. I'm going to change it. And I'm going to disable it. you will see the state is established but disabled. So the constraint has now been disabled. So I can now go back to where I was and do an update prod ord again and scroll down to 22209. This one looks good. I'm going to try now deleting this parent file with the constraint disabled. And it allows me to do it. No problem. What I have created here is I've created an orphan. The problem is, what's going to happen when I add or enable that constraint?
You will have an error, I think, because you won't find anymore the record from the product.
Exactly. You're going to get an error, but it's interesting because I suspect when I put this constraint on these two files, I didn't get any orphans. I was quite surprised. I have to take my hat off to you unless you doctored these two files, because it's unusual to see no orphans on a database file this big. So I compliment you on the cleanliness of your database. But what's going to happen now, I'm going to enable this, which, by the way, is the same as adding it. It doesn't make any difference. You add or you enabled. And check data, yes, and I get a message. It says key values for referential constraint are not valid. And if I refresh the screen, I get established, enabled, but check pending. It's telling me there's something wrong with this constraint. So even though I did get the error message, which I would get when I add the constraint, it also sits here check pending. And when a constraint is in check pending, you will have an error if you try and work with that file. Because a file that has check pending, it does not like you to mess around with it at all. So how do we find out what the problem is? Simple enough. Option 6, display the records in check pending. What?
Not display.
Eight. Constraint is not disabled. I apologize. The first thing you have to do here is, because the constraint is established and enabled, you have to first disable it. Otherwise, you can't do anything with it. Once you've disabled it, you can then use the 6, and it will actually show you the orphans.
Oh. That's good.
Now,
then in this case, you don't have any choice to delete these records.
at this moment, no, because I can't put the parent back again. I deleted it. So in order to get this to work, I'm going to have to delete these 5 records.
Yeah.
But this is the way where you'll find, if you have, and it's so easy, if you have dependencies, if you identify a dependency and you say, okay, I want to put a referential constraint here. define the referential constraint and add it, it will go into check pending if you've got orphans. It's the easiest way to check if your relationships are good. You can immediately disable the constraint and then you can proceed, you can carry on regardless, but at least you know you've got orphans. And you can find out what they are and you can work out what it is that's caused them and why are they there and whether you need to delete them or not. All right. Does that make sense?
Yep.
Is that okay, Marinus? Does that cover that?
It does, and I'm pretty confident that once the team actually start implementing it on more files, they will be very interesting conversations about how to clean data, because that is one of the remarkable benefits of this process, is that you're going to end up with dramatic quality improvement on your transactional data.
I have a question, Tommy.
Yeah.
There's a way to do on the other side. I mean that I'd like to delete record from the Promi P7, and there's a possibility to just do when we don't have any longer record for another to delete the record from the parent. There's no way to do that.
Not without writing a program for it.
Okay.
Because
I'm in the cascade, but in the other side.
Yeah, I know, but in the situation that we've got here, you're saying, how can I quickly delete those 5 records?
Mm-hmm. And I mean that in the case that I would like to delete all the record from the file and doing a cascade to delete the record from the parent. There's no way to do that?
No, you can't.
Okay.
It always, you define the relationship on the foreign key file, but you operate the relationship from the parent.
Yeah, okay.
So that is something one has to get used to. The thing is, if you make sure your relationships are in place, you should never have a problem with any orphans at all. So you shouldn't need to do anything like this. You shouldn't need to work backwards from the foreign key file upwards. You just go in and delete the parent, and the cascade will either delete the foreign keys or your after trigger will delete the foreign keys, whichever you've chosen to use. All right.
Okay. That's okay.
Wonderful stuff. All right. Now, having backtracked over what I missed, let's come back to COD's 12 rules.
Me?
Yeah.
I have a question for Luvic.
Yes.
I'm wondering if he learned something about CODs. Vic, do you know CODs?
COD.
No.
No.
No?
Dr. Edgar F. COD.
And what about normalization, Luvic?
A bit.
A bit.
Okay.
Okay. Because this is the tough one. I've left this to the end so you can't panic too much. COD was a British computer scientist. He worked for IBM from 1949, and he did a lot of research into the relational model for database systems. And he produced 12 rules, actually 13, which a database must obey in order to be regarded as a true relational database. Now, these rules can be applied to any database system that manages stored data using only its relational capabilities. So IBM is designed, DB2 is designed as a relational database. But the big question is, are you using it as a relational database? Or are you using it as a flat file database? That's the big question. And your database, well, if you haven't got referential constraints in that database, it's a flat file database that you're using. Right, let's see. These rules were intended to ensure that database systems claiming to be relational truly adhered to the principles of the relational model. And this is true. I hate to say, while few commercial systems fully satisfy all of COD's rules, and this is true throughout the industry, the rules remain a valuable reference for understanding the fundamental properties of relational databases. They also provide you with a target of where you actually want to get to. You want to get your database to be full relational database. So, rule 0, which was the first, is the foundation rule. A system, this may sound a bit silly, but if you think about, if you read it a couple of times, it makes sense. A system must qualify as relational, as a database, and as a management system to be considered a relational database management system. You don't need to be a huge scientist to work that one out. But that's his foundation rule. If you're going to, and I call the DB2 Relational Database Management System, RDBMS is what my term for it all the time. DB2 is implemented as a relational database management system. Rule 1, the data stored in a database, may it be user data or metadata, must be a value of some table cell. Everything in a database must be stored in a table format. What this actually means is that any piece of information, any item of data, must be a value of some table cell, of the intersection of row and column. And these must be stored in a table format, which is rows with columns. That's what this rule is actually saying. So you cannot store data in undefined strings. Rule 2, guaranteed access rule. Every single data element, value, is guaranteed to be accessible logically with a combination of table name, primary key row value, and attribute name column value. Now this is his second rule, which insists you have a primary key for every row. No other means such as pointers can be used to access data. Don't worry about the pointers we've been discussing because we don't use pointers to access the database in the files. So what he's saying is every single data element, an intersection of row and column, must be accessed by table name, primary key, and attribute name. No other way is relational. Systematic treatment of null values. This is a discussion that you guys must have amongst yourselves. The null values in a database must be given a systematic and uniform treatment. Now, you probably do not have null values in your database. More than likely because in the early days, the DDS database didn't support nulls. But since the arrival of SQL, nulls are supported in the database. So one must have a enterprise-wide decision about what null means because it can be interpreted in 3 different ways. The data is missing, the data is not known, or the data is not applicable. And they are very different. So you, as a whole enterprise, must decide how you're going to define null values in your database. Because inevitably you will get null values coming in. And null values can be very useful. You need to... I always used to have a problem when I had a situation with numeric fields. What do I put in a numeric field when its value can be 0 to 10 million? What do I put in that field when it actually doesn't have a value? It hasn't been entered yet. It is not valid. And in the old days of the 34, 38, 36, we used to put in a -1 to indicate that there has been no value assigned, because 0 is a valid value. But in this case, you would use a null. So data is not known, data is missing, or data is not applicable are the three ways of looking at things. Rule 4, active online catalog. This is COD's Rule 4. The structured description of the entire database must be stored in an online catalog known as a data dictionary, which can be accessed by authorized users. Users can use the same query language to access the catalog, which they use to access the database itself. That's what AO is. AO is a database catalog. It defines the entire structure of the database. It contains a data dictionary and the total database structure. So that is our answer to his Rule 4. Rule 5, comprehensive data sublanguage rule. A database can only be accessed using a language having linear syntax that supports data definition, data manipulation, and transaction management operations. This language can be used directly or by means of some application. If the database allows access to data without any help of this language, then it is considered as a violation. What I just did with DFU is considered as a violation of a relational database. He's talking here about SQL, or a SQL-like linear syntax. So this is a difficult concept to implement because we don't use SQL more than RPG. RPG is our main language, and RPG is definitely not linear syntax, although it supports data definition, data manipulation, and transaction management operations. So it's partly fine.
A small question about the SQL. Does it mean that SQL is a violation to use the database? No.
No, because SQL is linear syntax that supports data definition, data manipulation, and transaction management operations. So SQL is acceptable. It's not a violation. In fact, if you take this absolutely word for word, what he's talking about is SQL. That makes RPG a violation. But that's why this one is a little difficult. The important thing is this last sentence. If the database allows access to data without any help from a language, then it is considered a violation, i.e., if you can manipulate the data with a tool like DFU, you are violating the rules of a relational database. How many times do you manipulate data using DFU? Yeah.
Sometimes.
Don't answer that question. You're on the grounds that you will incriminate yourself. I know.
Or DBF. We can do that also with SQL. You know,
yes,
if you are doing an update directly on the file, it's kind of violation.
Yeah, that's also a violation. But if you put triggers and relationships and all that wonderful stuff on your database, then actually you're protecting yourself against that sort of thing.
As a matter of interest, are you guys using DBU at all?
We are using WorkDBF. Update that also.
Okay.
And yes, DFU is just to do research within, but we are using WorkDBF. It's a tool to directly update data, record.
Okay, so it's very similar to
update
DBU.
data.
Yeah.
Yeah.
Yes.
DBU.
Okay.
It's like
It's
DBU.
also
but
highly dangerous.
Marinus, Marinus, DBU, we looked at it. There's a difference between WorkDBF and DBU, and WorkDBF is using native record level access.
Okay.
And DBU is different. It's using more the SQL record level access.
Okay.
Which is a bit different. Sometimes you want something to happen, you want to have constraint or things like this. If you build something out of SQL on your database with WorkDBF, it won't work. It's going to be triggered only with DBU. And yeah, at one time, we were considering DBU.
Okay, well, that was just interesting.
Yeah, none of those tools should be acceptable. But
I agree.
I worked for a company who used to do this quite often. They used to use DBU to change data on the files because of a coding error or an input error or something like that, which blew their system up. And they used the ops manager used to go in and poke around and fix the data on the files. And the auditor said, that's not a good thing. You should not be doing that. You must get this managed properly through an application. So instead of doing that, they created a form which had to be filled in with the reason for the change and had to be signed by 3 directors before it was given to the ops manager, who then changed the data on the file. I don't think that made an awful lot of improvement on the situation myself. All right. All the views of a database which can theoretically be updated must also be updatable by the system. He's talking about joined views here, which theoretically can be updated, must also be updatable by the system. I'm not 100% sure what this particular rule is getting at, except that there are some views of the database which cannot be updated. They're non-updatable. High-level insert, update, and delete rule. A database must support high-level insertion, updation. That's a funny word, but that's his word. And deletion, it's not mine. This must not be limited to a single row. That is, it must also support union, intersection, and minus operations to yield sets of data records. Now you can see that clearly referring to an SQL style of operation. But in RPG, you can also do multiple record updates. So as I say, as he said earlier on in the beginning, the commercial applications can't always implement all of these particular rules. Changes to the physical level, how the data is stored, must not require a change to the application logic at the logical level. Oh, this is the holy grail of every IT department, is it not? There's a way of doing this, is that you don't use your physical files, you use logical files. And when you change a physical file, you create a new logical file that includes the changes and so on and so forth. This is actually not something, we've discussed this over and over again at every level. There are ways you can make it happen, but they're actually not worth the drama that you have to go through. What it's saying is I want to be able to change my physical files without touching my application code. And the only true way to do that on the IBM I is to write all your IO in SQL, define all the fields by name, and process the select clauses nominating all the fields you want to use, i.e. convert your entire system to SQL IO, not using select star, you naming every field that you want to select. That, if you do that, you can achieve this. Do you want to do that? In the next 100 years, maybe.
Maybe.
Logical data independence. The logical data in a database must be independent of its user's view application. Any change in logical data must not affect the applications using it. For example, if two tables are merged or one is split into two different tables, there should be no impact or change on the user application. And then the comment, this is one of the most difficult rules to apply. When you are normalizing data, you might merge or split tables. Let me tell you right now, you are going to really struggle to cause no impact or change to your user application. One of the most difficult rules to apply. Integrity independence. Integrity constraints must be specified separately from application programs and stored in the catalog. The database must be able to enforce integrity rules. All its integrity constraints can be independently modified without the need of any change in the application. This rule makes a database independent of the front-end application and its interface. The answer, in one word, triggers. Gives you complete compliance with Rule 10. That's exactly what triggers are. The database enforces its own integrity rules, and those rules can be changed independently without change to the application. This is completely and totally answered by application of triggers. Distribution independence. The end user must not be able to see that the data is distributed over various locations. Users should always get the impression that the data is located at one site only. This rule has been regarded as the foundation of distributed database systems. You don't have a distributed database system, do you?
Nope.
No, so your database is only in one place. There are some companies in the States that have branches or sites spread over 15 or 20 states and sites. And they use DDM, distributed disk management, so that it appears from any particular terminal, they cannot see that these database files are spread over the whole country. That's what this is about. It must not be apparent. And DDM, which is DDMF, which is a distributed database management file, is an object that can actually connect you to a remote data file. 12, the non-subversion rule, which is the last rule. If the system provides a low-level record-at-a-time interface, this interface cannot be used to bypass the integrity rules and constraints expressed in the higher-level relational language. I.e., if you use triggers, you can't get past the integrity rules by using DBU or work DFU or any of those other wonderful things. Yeah, I showed you that. You are actually restricted by the relationships and the triggers. Even if you're using SQL or any other tool at all, it all comes from the database. That's the non-subversion rule. Okay, those are the 12 rules. You will never be able to implement all 12 of those. It's just not possible, particularly with the size of your application and the scope of what you're doing. But it's a guideline. Certain of them you should actually try and achieve. And one of them is the non-subversion rule. That one, the distribution independence, the integrity independence. That's a very important one, because that is going to guarantee the quality of your data in your database. Also includes relationships. So those are COD's 12 rules of relational database management systems. And they are guidelines that you should be trying to aim for. Any question?
Why don't you talk, not talking about normalization?
You want me to talk about normalization?
No, I just question why don't you?
Because it terrifies people. That's the honest answer. I used to do this course, and I used to start with normalization. And by the time I'd finished with normalization, nobody was listening to me anymore.
I think the first time we had that session a few years ago,
yes,
yeah, you did talk about normalization.
And nobody wanted to listen to me after that, because all I could think of was, how am I going to do this? So normalization is something that will come. Once you start building your triggers and you start building your relationships, you will begin to see what you need to do to your files to make them, to normalize them. You need, Ludwig, you got a little bit of normalization from your training. Need to do research. I will tell you, I don't know whether you guys have tried using ChatGPT at all.
Not me, but Ludwig all the time.
All the time. Yes. Ask ChatGPT the question. Please describe in detail what database normalization is. And then if that doesn't scare the hell out of you, you could. I did that. I don't want to show you what he said. It's a very useful reference, quick reference. I use it a lot, but please, I've also forced him to update his database about 25 times already, because he gets it wrong, particularly with IBMI. So always qualify what you're doing, what you're hearing from him. What is it? It, him, they, her, they, them. So normalization is a process of rationalizing the database, separating files, like you saw with that diagram that I gave you, where I had a customer master file and address file. Put the addresses in a separate file, because there are rules to normalization. You must never have a field, the same field occurring more than once in a record, i.e. the occurs or repeating contents. These are the things that you've got to use in normalization. I'll talk about normalization, but only when you're getting into this trigger and IO server mindset. Then you will be more than happy to start considering normalization, but it's not necessary to gain a lot of benefit out of enabling your database to do work on behalf of your applications. There is a technique I've designed where you can take a file, take it apart, i.e. normalize it into 4 or 5 different files, and using triggers, before and after triggers, you can actually run programs that use the normalized database and programs that don't use the normalized database at the same time. You don't have to normalize every program that uses that file. There's techniques for using triggers that you can do that with. So I think if you start thinking about normalization, you're going to start forgetting about everything we've spoken about in the last few months. And I really don't want you to forget about those things. The next thing we're going to talk about, which I'm not starting now because we're close to the end of it, but we will do this on Thursday. And I don't think this will be a full session because there's not much my side of this JSON fence. We're now getting to the point where I want to show you why we've spent all this time talking about IO servers and triggers and relationships and everything that we've talked about up to now is all in preparation for handling this JSON interface to the graphic user interface. And it's the easiest way to do it. So we will talk about this on Thursday. It won't be a full session. So I'm not going to go now and get into that because I will only end up with a half-completed sentence and we'll have to call it quits. Okay. Any other questions? Anything else? Because basically, this is the last session for me. A last session this year, and I will be handing all of this over to Marinus and Clifford to educate you further in the new year. So any questions that you want, please ask.
But for me, that's okay.
Yeah,
okay.
Me too. Me too. That was interesting. Constraint is an interesting thing. We were not able to use them because at start a few years ago we were not journaled, so we were not journaling any of our files. Okay. So that was not an option. But today, yes, we could use it, and this way, I think using foreign keys and things like that simplifies the before trigger.
It definitely does. It enables you to ignore relationships because they're already taken care of.
Yeah, instead, that's less files that you are defining into the before triggers.
Yes.
So
and
this is interesting.
It's all designed to cut down the number of lines of code and to give you smaller blocks of code that you can test, confirm that it's all working, and then just park it and put it on a shelf and never have to test it again. So that's the route to follow. And really, if you can start moving towards that, anytime you have to change an application or a database file, move it, even if it's a little bit, even if it's only just generating an IO server and putting that IO server into one program. That's a step in the right direction. Okay. All right, guys. Well, we'll see you on Thursday for a short session.
Yeah.
And then it's holidays.
Yeah. But I'm looking forward to Thursday's session.
I know you are. You've been. This is what started all of this, wasn't it?
Exactly. So I'm kind of anxious to see that. So okay.
Yeah.
So let's wait on Thursday then.
We will start on Thursday, and then you're just going to have to contain your enthusiasm till the new year when Marinus can really get hold of you.
Okay. All right. Thank you very much.
Enjoy your day.
Thank you.
And,
okay.
Give Diane my regards. She's not sick. Is she sick, or was Joel sick?
Oh, yeah, Joel's sick. And,
give him my regards.
Diane is too busy, so okay. I relieved her. Okay. We have a lot of things to do before year end, so that's why.
Yeah.